Hi, good morning, everyone, and welcome to the Learning Tree in Microsoft Implementing End-to-End Machine Learning Lifecycle Workflows on Azure webinar presented to you this morning or afternoon, depending on where you are, by Ruth Yakubu. Thank you so much for joining us. My name is Darby Jago, and I am the product manager at Learning Tree for our Microsoft partnership. So before we start, I do want to take a quick moment to introduce you to the Learning Tree Anywhere platform. If you have participated in a Learning Tree class in the past as a live virtual attendee, you may recognize this layout as this is what we use in our Learning Tree courses. So you'll see that our presenter, Ruth, is in the upper left-hand corner of your screen. And then below Ruth is our chat box. This is where you can participate with questions or comments. And then in the middle there, you'll see the presentation. Of course, please feel free to use the chat feature for questions. We will get to those at the end of the presentation. I will be keeping note of those as to not interrupt Ruth while she's speaking, but certainly ask her those when we wrap up the presentation portion. Okay, so while I have you, I do want to present Ruth. Presenting for us today is Principal Cloud Advocate at Microsoft, Ruth Yakubu. Ruth specializes in Java, advanced analytics, data platforms, and artificial intelligence. Ruth speaks regularly at conferences and summits and has actually been named most valued blogger by dzone.com. So that's an impressive resume, Ruth. So we're lucky to have you today and appreciate you presenting for us. And I'm going to go ahead and let you take it from here if you don't mind.
Awesome. Thank you, Darby, for the introduction. And hello, everyone. As I was sitting and waiting, I noticed everybody is globally from different global locations. So this makes it extra exciting for me. Kind of like how Derby mentioned, my name is Ruth Yakubu. I'm a cloud advocate at Microsoft, and I'm on the AI and machine learning team. And today I'm going to be talking about how to implement end-to-end machine learning life cycles on Azure. So basically the agenda we're going to be going through is basically the normal life cycle that we normally go through, or sometimes we do it disjointedly, but the life cycle that normally data engineers, data scientists, machine learning engineers go through. So the very first thing we're going to be covering is data, around data preparation. How is that done on the Azure platform? The next thing is getting into training. So if you're to train a model, how do you go about training? What are the different options that Microsoft offers in terms of training machine learning models? Then we're going to get into analyzing your model, because yeah, it's one thing to train your model and see, oh, it has a high accuracy, let's go party, the model is ready to go. But is it truly doing what it's supposed to do, and can you really justify the results that you're getting? Then we're going to get into deployment. Well, in deployment, the different options that are there and things to consider when you're deploying your AI and machine learning models. Then finally, we're going to be talking about monitoring when you're dealing with AI models. So I hope everybody's excited based upon the agenda that we have. So to get started, let's take a step back. When we talk about the machine learning life cycle, there are multiple, typically there are multiple um, teams or people involved in the end-to-end life cycle. You have data scientists, you have data engineers, you have machine learning engineers. And sometimes all of these people are one person in an organization. So basically, the key thing is when you're embarking on training a model, the number one thing, mostly when data scientists come into the picture, is working very closely with the data engineer that is going to be analyzing the data based upon what the end goal, what we're trying to uncover or predict out of the data. So they'll be analyzing the data and cleansing the data. And from there, they work very closely with the data scientists, because from there, the data scientists can also work on, okay, given the data, given the use case that we have, what frameworks can we choose? What environments can we choose? What algorithms are best suited for that use case? So that's when you typically need the expertise of a data scientist. Then the next thing is, okay, you trained your model, you need to register it, and the key term register, we're going to get to it, because what does it mean? Register where? So we'll get into that. Next thing is actually deploying it. So, okay, it's being deployed. So there are different, what's it called, targets that we deploy models now. Sometimes it's cloud applications, sometimes it's at an edge device, sometimes it's just on a hardware environment. So when we get to that area, we'll dive deeper into that. Then most cases, we get the model. Yes, everything looks good. We put it into production. Does that mean we rest assured that the model is always going to work? That's where model monitoring comes into picture, to make sure your model is performing as you initially trained it to. Because the data can get stale, and you can have like data drifts in your data. Then another interesting part is machine learning engineer. And machine learning engineer, this is a very tricky title. It's just basically anybody that is doing the end-to-end coding and managing these models. So they'll come into the picture and help with the whole life cycle, monitoring it, seeing whether we need to retrain and that type of thing. So as you can see, this is a continuous iterative process that we go to. For a lot of us, if you started with application development, it looks very similar. It's those type of life cycles. So how does all of this apply to Azure, and especially Azure Machine Learning Service? So Azure has a machine learning service that gives you the capability to train your models in the cloud or on-premise, remote. Gives you a SDK. So the Azure Machine Learning service actually comes with SDK. So there are different capabilities, things that you can do on the portal You can also do programmatically, let's say like in a Jupyter notebook or whatnot. Then also, we also have CLI capabilities, so you can also do a lot of the tasks in terms of training the whole life cycle with command line CLI tooling. Then we have the Microsoft Machine Learning Studio. That's where all the action happens. That's where you have your notebook. There's a for people that prefer low code, no code. We also have a service for them. Then if you're in between, whether you like the visual drag and drop low code or you like the hands-on, there's also auto machine learning. Now, auto machine learning, it can span from beginners to experts in machine learning. We can touch briefly on that. Then you also have the compute. Where is all of this training going to take place? So back to the checklist of the machine learning life cycle. What does it enable you to do? It enables you to prepare your data. It enables you to build your data. I have a control in front of my screen. Enables you to train your data, manage your models, and track your experiments, and also deploy your models. And we'll get into details regarding that. So let's start with data preparation. One thing to note about Azure Machine Learning, the workspace is built for collaborative environments. So let's say you work in an organization where there are multiple people working on, integrating coming in different parts of utilizing the AI model or training or consuming. That workspace is a central collaborative end-to-end cycle for multiple users. The very first thing that the service offers is something called data stores and data sets. So the thing that makes data stores unique is there are different ways of how we access data. We could have data on our local environment, but we need to upload it. Let's say we have like a zip file of a whole bunch of CVS files or image files. We need to load it to, let's say, the blob storage or any data lake. We can upload it in the data lake and utilize that for our training. It could be the data is coming from another data source. So let's say you have Azure Databricks. You have Databricks. You have like big data. You're running analysis or data cleansing or data pipeline type of activities with Spark. You can easily utilize that data, or if you're using SQL Server. So the key thing, and the third scenario is a lot of us, especially when you're in the initial stage, data is very hard to find when you're trying to solve a problem. Sometimes you don't, well, most times we don't have data. So maybe we go to maybe a third party, Kaggle is there, that we can find data sets or academic entities that publish data for people to use for training. So that's via web links, internal cloud storage, or local file upgrades. So what data store, what data store provides is just the connectivity. It provides links to those data source for you to utilize. So it doesn't, let's say we're dealing with, let's say SQL Server database, we're analyzing data to be, what's it called? To be trained. It doesn't make sense to load all of that data onto the premise, or especially if you're dealing with third-party data. The good thing about it is it provides connectivity information to that entity, but that's all it does. It provides a black box for you when you're programming within your code. And that's where data sets come into picture. So as data sets in your code, the same way that we load data, let's say using pandas, we're loading the data frames. What you see is grabbing data from the data sets, but where that data came from, you don't know. It's a black box for you. So you don't have to worry about authenticating, getting that information when you're utilizing it. So those are the main key differences in with dealing with data sets and dealing with data stores. And the good thing is it also adds another layer of security when you're dealing with data, especially when multiple people on the team are accessing the same data. It's a way to provide a layer of security around that. So we can go to the next link. So this is a better visual of what I'm talking about. So we have in Azure, we have something called Azure Blob Storage. So that's where you store files or objects. So depending on the type of data that you have, let's say you have a whole bunch of data that you just need to load locally, you can load it from a local file. If you're using other data sets from the cloud, you can, the data store just provides links to that. Then if you're using a public URL, that's another way that you can load data to the data store. Then the data set is what you know. So you interface with the data store in order to grab the data and be able to do your day-to-day tasks. So whether it's training the data, having some kind of automated learning, if you're dealing with pipelines, and using Designer, you can utilize that. And also around data drifts. That's another area that we're going to cover, because the question is, let's say you have your model deployed in production. You used a certain data set when you trained your model. So there's a way you can keep the baseline data within Azure, and part of the monitoring is it's going to be monitoring both the data and the performance of the predictions, and be able to notify you or spot whether there are anomalies or if your data is getting stale. And we'll get into more details around that. The next thing is, let me actually show you guys a demo of a data store. So let me close this window. Can you guys see the screen? Somebody say yes or no. Do I need to enlarge it? Okay. Okay, cool. Um, so this is a snapshot of when you create a Azure machine learning service. It creates a workspace for you. So within the workspace on a high level, you go into the studio, and the studio provides all the end-to-end things that you need. So at the very top, kind of like how I was mentioning, if you want to run your own Python code using the notebook, you can click on this and start coding in the Jupyter notebooks. If you want to use the automated machine learning, which is also low code, no code. It's a very useful tool. You can select that. Then if you want to use a designer, which is basically drag and drop, you can utilize that. So these top entities are basically what well, we'll get into the different areas. So since we're talking about data store, this is how a data store will look like for you. So when you click on a data store, basically all the different data that you're using within the workspace is stored here. So with this one, I loaded a whole bunch of images for MNIST experiment. And if we click on it, that's basically links to the data set. Then also data sets. So it creates links for you to look at. The next thing is, give me a few minutes, overview. The next thing is the data sets. So if we drill down to the data set, when I loaded the MNIST data set, I loaded it and named it. When I was registering it in the data store, I called it MNIST open data set. But the cool thing about it is when you open it, it gives you the URL that if you're to load, this is what you actually be loading using the, let's say, pandas data frame. The next thing is, the cool thing about this is when you're also using the data sets, if you notice, it already provides data for you to copy. So if you need to access the data set, you can just copy this, what's it called, Python code, and just paste it in your code and utilize this data. So yeah, these are the paths, those are the names, and also when you're creating experiments, this is a situation where, let's say you have a whole bunch of data. The data engineer came and cleansed the data and is good to go. And you can use the data in an organization for other machine learning experiments. This is very handy because given that data set is also a good audit trail to figure out, okay, what other experiments utilize that data. So it's kind of good for tracking purposes and auditing purposes when you're looking at the data. And If you guys have questions, feel free to um, hold those if I need to expand on that. The next thing is the actual training of the data. So with Azure Machine Learning Workspace, we have also another entity, and this entity is basically where you experiment, where you actually run your experiments. So whether you're using um, Python or Spark. You're also using different environments like containers and whatnot. Encapsulate everything about your experiment into experiments. The good thing about experiments is you're able to develop your script, run it, and everything that's happening in your script is being transparent on the in the experiment. So let's say you're working on a training that maybe is taking weeks or months. Every run that you run, everything is what's it called, captured and versioned within experiments. The good thing is, let's say after some time your experiments are getting worse and worse, you can easily go back. Another good thing is you can easily reuse your models that you created in the experiment entities. You can also deploy your model. So let's say I'm in the Jupyter Notebook, I'm running it locally. You can deploy it straight to the experiment, and it'll store your experiments and all the details around the experiments. If you're familiar with MLflow, like metrics and registering models, it has that capability as well. And the good thing about experiments is you can also, it doesn't have to be experiments that you ran within Azure Machine Learning Workspace. You can also bring in models that you trained externally. So this is good for reproducibility. It's good for cases where you need to be audited because it's keeping a good audit trail, and also portability if you need to run it in also different compute environments. Then the next thing are runs. And runs are basically the scripts that you actually run. And you group all the different, I'll say runs like each time you execute an experiment or run another trial. Let's say there's a bug and you rerun. These are just runs, and you store all of that under an experiment. Then experiments just groups all the runs, the run history that you have, and everything belongs in one space. Another thing is, okay, what's encompassed in these runs? So with these runs, when you run you're training your models, all these different iterations is keeping time of, let's say, duration. Maybe you ran it at the end, it was accurate, but how long did it run? Maybe you need to optimize your training. Keeps timestamps, versioning. Kind of like how I mentioned, it also keeps track of all your metrics for excuse me, for tracking purposes. So a lot of us, hey, you train a model, you try different parameters, try to tune it, And after a while, you got like the perfect happy medium in your experiments. But the question is, when you come back and you need to reproduce, what were the different, what's it called, parameters or tuning or settings that I use for that experiment. So those are things that you can track within your metrics, and it does a good job capturing all of that. And everything is automatically saved in your under your experiment. The good thing is, when you're running your models, you can also run it against different compute environments. So you can set up instructions on how you want your run to run. So like, what's the target compute entity? Excuse me. Okay, so the next thing is the models. So models are artifacts that are also kept within an experiment. Kind of like how I mentioned, an experiment is an encapsulation of everything that you're doing in your experiment. So it stores all of that. And no matter where you ran your experiment, whether you did it manually, whether you did it on the cloud, in the portal, you did it locally, you use a designer where you're just dragging and dropping the functionalities and the algorithm, and it trains everything for you. Or you do auto machine learning where you just load the data, specify that, look, for this problem, I know it's a regression or a classification type of problem. Auto machine learning will run it, but guess what? It'll still store everything nicely into your experiment space. Excuse me. Then the good thing is, with all of these different areas of how you can train your models, everything is being registered. It's very good for traceability, like I keep mentioning. We'll get into deployment later, because of course, within the experiment, you have the capability, once you look at all the experiments, let's say you ran 50 different experiments and you found one that was like the optimum one within the experiment entity, you'll be able to, excuse me, you'll be able to deploy to your target location that you prefer. Then the next thing is super, super important. This is around model interpretability and fairness. So at Microsoft, we take responsible machine learning and responsible AI very seriously. And this is basically ensuring that you're able to train your models, that they're fair, they're able to, you're able to demonstrate accountability if you're to be audited, or if you have a testing team that is checking to make sure your model is trustworthy, and is something that can be accountable. You can use responsible AI, and transparency is also important. And this is not just with the developers. Sometimes you have stakeholders. Sometimes you have customers. Like, let's say in a healthcare situation, you came up with a model that predicts diagnostic information. But the question is, are you able to explain reasons why you think is confident, and how do you debug when there are issues, and how do you know that it's not completely accurate or fair? So all of this is to eliminate bias. You also have um, security concerns and accuracy. So the good thing about the responsible AI that dashboard that we just announced about a week ago at Microsoft Build is the ability to give developers the ability to debug their solutions, to be able to find biases. So if you make a prediction is, let's say, 90% accurate, you're able to look at the features. What are the features that led into this? And is there a certain demographic that is benefiting more from your model versus another? You can also debug. Maybe they are like doing error analysis. Your model may not be up to par, or I'll say as accurate, even if it has a high percentile. But when you're able to drill down, you're able to see, okay, what are the features that are leading to this error? And the good thing about the responsible AI dashboard is you're able to come in and be able to adjust and evaluate a lot of these different areas. So it's a very robust capability that is I highly recommend you guys diving into it, because it's not just us or people having discussions about, okay, eliminating bias, but is giving you the ability to debug and also justify and bring credibility to your model. So that's a very exciting tooling that we've incorporated. As you build your models, you can easily add it to your Python coding or YAML configuration. If you're using command line CLI, you can also add those. And basically, it does a good job mapping your inputs and outputs from training to actually registering your models and looking at the holistic way you went about training your models. So it's very good to debug your models. And the good thing is it also has a way of giving you a score of how fair and accurate your model is. Okay, it looks like we have 10 minutes. So as an example of responsible AI, this is one of the dashboards, one of the information that it provides. It shows when you're looking at, let's say, accuracy, it'll show you the disparity of, okay, for this someone is looking at how likely are uneducated people are going to be hired versus uneducated. This is the bottom half of it. So if you have a degree, I take that back. If you have a degree versus a non-degree person, I apologize, I should have used uneducated. There are multiple ways of it being educated. But if you have a degree versus not having a degree, you show, okay, what is your distribution of um, your data set? Where did most of the prediction go? And are they gaps? Let's think of, let's say, a loan. Is there a disparity into gender or somebody who is married versus, let's say, a single mom? Are they being approved for loans? So there are multiple things that you can look at. Then with if you're looking at accuracy, okay, um, for the non-degree ones, how likely did you under predict versus over predict in these areas? So these are just on a high level, but we have a lot of dashboards that are collected. And the good thing is in real time, you can adjust some of these feature fields and be able to see how it improves or degrades your model. So that's to bring, analyze and bring accuracy and fairness into your model. I think I've been skipping some demos. Okay, so the very first demo that I want to show you guys is the very first pane that you see here is all the notebook experiments that you have. So let's say I want to do an experiment to classify like an MNIST classification, whether a handwritten number is 1 or 2. Here's an example where you create your folder and your projects. And for the first one, the key thing is under experiments, using Jupyter Notebook. If you notice, this is a Jupyter Notebook. It shows the compute that you're running on, the level of Python that you're on. The very first thing is actually creating an experiment. The next one is linking to your workspace. And all of this can be done offline. Like you see something called workspace configuration. If you're working, let's say, in your local or remote environment, this field is located right here. You download it and have it in your where your Python code is, and you'll be able to run your code. So this is what the experiment is. The very key thing is defining what the experiment is. Once you define the experiment, it creates an entity that everything is going to go under. You need to specify your compute environment, and the compute, the good thing about this is everything is clickable. You can see, okay, where are all my computes? If I just want computation, if I want clusters, if I want inferencing computes, like deploying to Kubernetes, I'll do that. Let me go back. Sorry about that. Okay. So you specify the compute, you bring in your data. So with this one, if you notice, I'm just referencing the data set because the data that was loaded and authenticated, if there was authenticated, is in the data store. So all of that is a black box to me. I bring it in, I load it, download the data. And another good thing is, let's say after you cleanse it, you want to register it back to the data and tie it to this experiment. That's a good thing, because for every experiment that you run, the data that you ran it on is going to be linked to that experiment. The next thing is just you write whatever code that you're training that you're doing. So with this one, we're trying to predict whether the handwritten is actually the right prediction for image recognition. Another key thing that you should be aware of is once you're done with your experiment, the good thing is you can create your image, a model image, like a Docker image for your model to run in. So with that, you specify what the dependencies are. If you're using scikit-learn and all the different libraries and whatnot, you specify with all of that. That's pretty much some of the highlights. The rest, if you see like run details, like I mentioned, run is actually what grabs the metrics, the details of your experiments. So it will be bringing back details about your experiment. So those are gathering metrics. So this part was just to run an experiment. And when you're done, if you notice, run is going to just register the model. And run is also a subset of the experiment, so you don't even need to tell it which experiment it already knows. Then when you're ready to deploy, oh, those are dependencies. When you're ready to deploy, the good thing is you'll be able to specify, sorry about that, you'll be able to specify the type of environment that you want. So for production, okay, I want this model to be deployed to a Kubernetes cluster. So basically what you need to do is, well, I'm registering the model again and creating the Docker image. Then this scoring file is very critical because this is what's actually going to be running in your container. So this init part is what actually loads your model into your application or the container. So once you load the model, you're just telling whatever and application that's going to be consuming this your model how to run it. So the next thing is, okay, to run it, just pass in file. It's going to be in JSON format. You already have your model. You invoke the prediction on the data and be able to get your data. So this part is a critical part. You can choose to deploy to like a Kubernetes cluster, but the good thing about Azure Kubernetes is it's a managed service, so a lot of the heavy lifting is done for you. But for this one, you specify, okay, how many CPU cores do you need, the memory, then, okay, what about auto scaling? Like if the compute, your service, your nodes are running, if it hits a certain threshold, how to auto scale and also descale. So once you have all of that, you're pretty much set to deploy your model. So you specify your environment that you're going to be using. So that's the container environment, then the service. You actually deploy it into your experiment. Um, and this is just validating um, the code. So let's get back. The question is, number one, where is the experiment? So this is where all the experiments that you run are going to be. For this one, I ran it multiple times. So for each run, you'll have like different runs. But if it's currently running, it will show you the run information. If you click on one that actually completed, you can, these are the metrics that I was talking about, okay? The accuracy, the, what's it called? Regularization rate. If you want to do the what's it called, standard mean estimation or standard deviation, you can incorporate all of those. But this is the good thing about the model, that it gives you the experiment gives you the model that you use. It also gives you the environment that you use. This is the container image environment. This is also the experiment. You can go into metrics. If you collected more metrics, it'll display all of that. Then where is your model? The model, if you go to the outputs, it has information about your model. The logs are also very important for you to help trace all the things that the logging when you were actually running your experiment, and you'll be able to, if there are errors, you can find errors. The code that you wrote, it also keeps track of all the Python code. Then for explainability, that one we didn't set, I didn't set that, but explainability is okay, what features led to this prediction, so it will show the distribution of that. Where responsible AI, the different aspects of responsible AI will go here, but for this was just like a hello world MNES experiment, so we don't have the responsible AI because we didn't configure that. Then monitoring. Okay, so let me quickly go through some of the key areas, then we'll be wrapping up. Okay, so the good thing is I covered the deployment. So with deployment, one thing that is very important when you're creating your workspace, the Microsoft workspace goes and creates a container registry for you. So that's where you can store your Docker images. When we said we wanted to deploy to Kubernetes, this is actually the Kubernetes service. So you can actually go in there and manage it. These are the data stores that are there. If you notice, we're dealing with Key Vault. The storage, the data storage is encapsulating that. So it maintains the keys. Even Microsoft doesn't have access to the keys, but the service is self restricts all of that. So these are things that you can do. You know, you can Dockerize containerize your image. You can deploy it into a web service. So when we had that image and we said we needed to deploy it into Kubernetes, guess what? It did. Oh, before I do that, when we said we wanted to register the model, when you do the register, it actually registers the model. So let's say you have a whole bunch of experiments, each experiment, each trial will have another run ID. This is where all your models that you decide that these are good models, I'm ready to use this one, you can register here and also click on deploy and do the same thing if you want to deploy it to, let's say, a Kubernetes cluster. So all of that, just in case you didn't do it code-wise, you can do it image-wise. And all of this, I want to remind you guys, you can do a CLI, you can do it with the designer, which is just drag and drop. Everything is visual and very easy to utilize. So how does the endpoint look like? So we talked about a lot of people involved. We talked about the data scientist, the data engineer, but what about the developer? When the code is ready, we need to give the developer an endpoint. So this is the REST endpoint of your service, your model that you just deployed. But the thing about this, and it has Swagger, so you can figure out how to utilize it. But the good thing about it is you can actually test it. You can provide data to it and be able to test the APIs. Okay, so yeah, you can provide a JSON since the scoring provided said, hey, we're going to use a JSON format. You provided JSON input here, and the output would display. Since this is blank, that's why you see this error message. It's nothing. It's just because
Hey
it's blank.
Ruth, it's Darby.
Yeah.
The demo forgot to share on this portion right at the beginning of what you were presenting. Would you mind showing the screens from the very beginning part of this demonstration? Some of the attendees missed that because it wasn't.
Okay. Let's try this again. Can you guys? Oh, okay. I'm trying to
We can
think.
see now.
Okay. So what I was mentioning that, remember how we deployed, we registered the model. The model, when you register it, let's say you have a whole bunch of trials and you're like, aha, I want to register this one. You register the model. There's an area where all your models are. You can see the run number. You can see some details, the version, and other information like the data, okay, what data was utilized and whatnot. I didn't have those settings set on. If we also enabled the responsible AI, we configured it, you can also go deep into that. If you're familiar with ML Flow, it's the same as registering a model, but the good thing about Azure Machine Learning is everything is collaboratively end-to-end in one place for you. One thing I was mentioning in the code, we said we wanted to deploy to an endpoint like Kubernetes. So, okay, you can say want to deploy it to Kubernetes cluster. Or if you have like a small utility type of service that does not need that much manpower. You can also use Azure Container Instance. Works the same way. You'll be able to consume that. The last point I was trying to make is we had different people in the organization dealing with this AI machine learning cycle. So developers are sitting there, okay, when do I incorporate this into my model? So the good thing is you can give them the endpoint of the the REST endpoint. You can give them the Swagger, how to utilize it. You can test it. So if you notice in the slide that I showed in the experiment, the scoring that showed, okay, when you have a model, load the model, then this is how you run the prediction. It was just like 3 lines. This is, it created a window because it's expecting a JSON, so you can easily put test data and run it. Because I don't have any data, it'll, what's it called? It's throwing an error, but if I have data, since time is of the essence, I cannot upload an image, but yeah, if I provide a payload, yeah, it'll be able to predict whether the handwritten number is 4, 5, or 6. Another critical thing is everything has to be secure. So we're trying to help the developers. So you have the endpoint to use this in any application or deploy to whatever endpoint, edge device or whatnot. Thing is, you also need keys, secret keys to authenticate to get into it. And another awesome thing is, just in case you need help getting started, like, okay, how do I get started actually consuming these? We provide examples of how you can choose your language and be able to utilize that. So let me quickly wrap up. So that's basically what I was trying to say. I'm not sure whether the audience saw that when you deploy, when you create Azure Machine Learning Workspace, number one, it's going to come automatically with the Azure container registry. If you have Docker registry, that's fine, but it's expecting you to create scalable solutions. When you select that you want to deploy the model to a Kubernetes service in Azure, this is Azure Kubernetes service, is what's it called? It's a managed service, but you can also go in there directly and manage your models. This is a workspace that has all the experiments. This is, if you want to get, when I was talking about security, it's about the data store. When you load your data, authentication, all of that is stored, and credentials is a black box to you. That's what the key vault is securing all of that. Then the data store, this is where your data lies. So let's quickly wrap up. Okay, so this is what we covered, how to deploy it to a Kubernetes cluster. This is inference. The scoring model that I was talking about. We also have links in the chat that you can reference and see exactly all of these, the details of everything that I'm mentioning. This is just to show you the capabilities that are there. Yeah. So kind of like how I mentioned, auto scaling, you can set all those settings for auto scaling when you're configuring your Kubernetes instance. Then another area that's very critical is Onyx runtime. So Onyx Runtime does a good job optimizing your model and also accelerating the runtime. So what do I mean? Your model is probably, when you have your model, okay, you deploy it to your end hardware. Is probably taking up some space, so it helps condense it. But the key thing about Onyx that really shines is its ability to astronomically speed the runtime of your models. So this is very critical. It's I didn't Yeah, there's another demo. I'm not going to get a chance to show you, but the good thing about Onyx Runtime is no matter what framework that you're using, whether you're using PyTorch, you're using scikit-learn, you're using TensorFlow, whatever model that you use to build your model, you can convert it into Onyx. And in Python, it's literally 3 lines. If you have a model and you need to convert, and the conversion, depending on which framework you're using, the converter, there's a tool for that that can easily do that. The good thing is you can, like I mentioned, you can deploy it to whatever hardware, and it accelerates the runtime on the hardware. So whether you're running in the cloud, you're running it on an edge device, or within an application. And the good thing is, if you have your own different language, let's say you're coding in Java, C, Python, you can easily use the Onyx runtime. Just call it within your, what's it called, your source code, like any other web service. Um, I'm just going to show you a quick screenshot of how the Onyx runtime looks like, since we're at time. But the same thing that we did for MNest, for the Onyx runtime, basically it your code does not change. You use the same code that you use for your programming. So for this one, it was written in PyTorch. So you train your model. When you're when you're done with your model, when you're actually exporting it, you first save it as an Onyx. So in PyTorch, there's already a built-in function for Onyx to be able to convert your model into Onyx. Then if you're to deploy it, you can easily, just same as what we did for the MNest, okay, my screen is a little slow, but same as when we did the model register, same command line, nothing changed. You just swap from, let's say you use scikit-learn, okay, that model for scikit-learn, just swap to the Onyx, give it a path, and tell it to register. It's going to register into your experiment the same way you deploy to Kubernetes or whatever endpoint that you're deploying to. It'll deploy and work its magic. So that's basically about Onyx runtime. There's also links for you to go into more details around that. The final part is monitoring. So with monitoring, the Azure Machine Learning provides a lot of metrics for you to um, monitor. So when you're in the workspace, the good thing is you can set alerts based upon what's going on. You can create rules. You can capture, configure and capture different things that is going on with your model. And you can also select the way you want it to be displayed and also the time frame. So there's monitoring there. But the part that I really wanted to bring to your attention that is very important is part of the continuous, the life cycle of a model is around data drifts. And given the time, we've also provided links for this one. But data drifts is basically when you deploy your model into production, there are multiple things that can happen. The world can change. We just went through a pandemic, data change, and your model is not working. Or the data that you trained your model, the way of doing business has changed, so your model has gotten stale. Or let's say you have sensor devices out there that's sending sensor information and you gathering it to do analysis. If they change to another model, let's say some kind of electrical gadget, and the metric, the unit of measurement of the telemetry information that is used to sending changes, those are things that can degrade your model. So the good thing that Microsoft provides is this continuous monitoring of models. So same way, when you're training your application, when you load your data, load it the same way. But the key thing is you need to register your data into the your data set into the data store. Whatever data, after doing the cleansing and whatnot, that you're gonna build this model on and deploy it, register it into the store. So that's your baseline data. That's the data that was used to, what's it called, to train your model. The next thing is the data has to have some kind of timestamp. So you maybe is patient information, just tack another column that has timestamp because you want to be able to monitor over time. So the good thing is you're able to configure, oh yeah, you also specify a little compute because this is going to be running over time. So you just a small compute. You can configure it, provision it and point that, okay, I want the data to the analytics for the data to run on the compute, the target compute. The next thing is, okay, we do have the Azure machine learning has what's it called? Library or object that handles data drifts. So you specify what the target is. So the target is actually the what you want the data to be. So the today data. How frequent do you want it to be grabbing the data? You also want to specify the threshold, okay? How, if my data deviates, like when do you want me to start alerting you? That sort of thing. Then yeah, you upload. For this particular instance, I'm using weather. Weather changes over time. So all of this, you specify the components. Oh yeah, and you also specify the features in your models. because it could be one of the features that changes. So those are part of the analytics that you'll be looking. So this is an example between this date and this date. You can be looking at how the model is progressing. They also have a start date and an end date of the timestamp for your data. Then you're able to call the monitor. Now that you've done the configuration, you send it to the data store, and when you call this monitor, it's just turning on the monitor and saying, hey, I want you to start backtracking from this time and monitor the performance and start giving me stats on how my data is performing. So in essence, that's basically it. Let me show you an example of what that looks like. So this is one that has been up this morning just to show the metrics. So between this time and this time, how is our data behaving? So for this one, it's pretty steady, so we don't need to worry too much about that. Give me 1 minute. I believe it's this. Yeah, so these are the type of information that you're gonna start seeing over time within a certain period. You see how your data is performing in over time. Oh yeah, another thing, you also need to set how often you want to capture this data. Is it every hour? Is it daily, weekly, and whatnot? But in real life, this will take a while before hopefully your data, your model becomes stale. So that is basically in a nutshell. And if you want to also go into more details, the metric part that I pointed out shows a more detailed information, a breakdown on what's going on with your data over time that you can measure and see, okay, what maybe is certain features that just went haywire, so you know exactly where to go and retrain your data. Of course, we capture multiple things within your experiments. You can also see let's say the degradation of when you're running your experiments, like how your models were performing while training over time and whatnot, and how it got to the optimum state. You can measure different metrics that we capture. So there are different ways, lots and lots of different information that comes in that will give you good insight on how well your model is. You can monitor it and be able to make informed decisions. So in conclusion, machine learning is all about going through these life cycles, and the key thing about Azure is creating the Azure Machine Learning Workspace to be a collaborative environment for different people on your team to utilize. You can use the integrative with your apps. You can do testing like the old-fashioned way. We're going back to the basics, but all the basic stuff into um, what's it called? Development, application development also applies to machine learning. So testing, having another team or another person that does all the testing is essential. Releasing, how are we releasing our information? Then monitoring is a continuous monitoring. Then the tooling provides awesome other features that we didn't even get a chance to cover. Um, for example, pipelines, but that's another conversation. So thank you so much for taking the time today to learn about Azure Machine Learning Service.
Thank you, Ruth. I appreciate it, and I apologize that we did run over today. Glad to see so many did stick around. I'm gonna skip the Q&A just because we did run out of time. But if it's okay with you, Ruth, I will email you the questions, and I should have the contact information for the folks that did ask a question, so I can send them your response if that's okay with you.
Yeah, that's fine. And if you can paste
Okay,
the
perfect.
links in the chats, I think it will be very helpful for the attendees.
I
Um,
did do that.
yeah.
I did do that when you said it originally. So I think we just they got pushed up a little, but I will again. And I will also send an email to participants afterwards. You will have access to these slides, so you can certainly review them again if you would like to. If you haven't participated in a webinar or a course in the past, just keep an eye out on your email. It'll teach you, or show you rather, how to log in and access those. And quickly, as you can see from the slide here, we do have some incentives that I would love for everybody to take advantage of. We have some complimentary courses that include the exam voucher. So we're looking at the AZ 900, AI 900, DP 900, and PL 900. As well as MS 900, I think in the UK we have coming up. So here are the links. I'm going to go ahead and paste those into the chat as well. Please feel free, to register yourself if one of these times works out with your schedule. This is a great follow-on to what Ruth was able to present for us. And yeah, we'll look forward to getting those questions over to you, Ruth. And, Janelle and Nicholas and Mike will get those answers over to you as well. Thank you, Ruth. That was seriously excellent. So thank you so much.
Thanks, everyone.